Student, so now we're going to learn about 3.1 Newton's universal law of gravitation. So, kita akan fokus yang pertama, which is gravitational force. Okay, gravitational force, we have the Newton universal law of gravitation. So, Newton universal law of gravitation ni, dia state that gravitational force, which is F, is directly proportional to the product of mass of the object and inversely proportional to the square of the distance between them. So that means the formula is F equal to G, which is universal gravitational constant, M1, M2 over R2. So as you can see here, F is represent the gravitational force between two objects. So universal gravitational constant have a constant number which is 6.67 minus 10 to the power of negative 11. So you have to remember for the G values because it's constant number. And we have M1, which is mass of the first object, M2 mass of the second object, and R is a distance between the center of the two objects. So this is the picture. As you can see, we have two objects here, and we have R is distance between two objects, the center, distance between the center of two objects, and we have F, both of them, is gravitational force between two objects, and we also have M1 and M2. So, as you can see, F1 is equal to the F2, and because of this formula, F1 equal to F2, we have F equal to G M1 M2 over R2. So dekat sini, Newton Universal Law of Gravitational ni, dia explain bila terdapat dua objek akan ada satu tarikan gravitational force between two objects. Okay, let's move to the next 3.1.2. Factor that affect gravitational force. So, the factor yang akan affect gravitational force, we have two factor, which is mass of the object and distance between object, which is R. So, for the mass of object, the relationship between gravitational force is when the mass is increased, gravitational force is increased because gravitational force is directly proportional to the product of the mass. As for the distance between the object, so the relationship between distance and gravitational force is when distance is increased, gravitational force is decreased because the distance is inversely proportional to the gravitational force. For the mass, we have mass is directly proportional to the gravitational force. Okay, so let's move to the next. Okay, so dekat sini, kenapa bulan boleh berpusing di sekeliling bumi? So, because the moon have an orbit around the earth, as there is gravitational force between moon and earth. So, bulan boleh bergerak sekeliling bumi sebab ada orbit sekeliling bumi dan menyebabkan tarikan gravitational force between earth and moon. So, the planet around the sun, gravitational can orbit because of the force imposed between the planet and the sun. So, lukisan ni boleh dikaitkan dengan lukisan matahari. So, the planet-planet lain boleh mengelilingi matahari mengikut orbit dia sebab dia ada gravitational force yang menyebabkan ada the force antara planet dan matahari. Let's move to the example. Calculate the force between two objects that have mass of 1000 kg and 5000 kg separated by the distance of 2 meters. So first we will have to write the formula, which is F equal to G m1 m2 over r squared. Okay. So let's move the paper here. Okay. So just put the item that have been given to get the answer. So G, we have a constant number which is 6.67 minus to 10 to the power of 11, and we have mass 1 which is 1000, and we also have mass 2 which is 5000 over 2 to the power of 2. Okay, so the answer will be 8.34 minus to the power of -5 Newton. Okay, let's do example 2. Calculate the gravitational force between a durian and the earth. The question given, mass durian which 2 kg, mass of the earth which is 5.97 multiplied by 10 to the power of 24 kg, and we have distance to the earth which is 6.37 multiplied to the 10 power of 6. So, first we have to write the formula first, which is F equal to G m1 m2 over r squared. So let's put the all component here. So G is a constant number which is 6.67 minus and multiple to the 10 to the power of -11, and m1 we have 2 kg, and for the m2 we have of 5.97 multiple to the 10 power of the 24, and we about r squared, so 6.37 multiple to the 10th power of 6, and put a bracket here to the power of 2. Okay, so when we calculate, we get the answer is 19.63 Newton. Okay, so let's move to the next example, which is a rocket at a launching pad experienced a gravitational force of 4.98 multiplied to the 10 power of 5 Newton. What is the mass of the rocket? So it's asking the mass of the rocket. First, we have to write the formula. Gravitational force F equal to G m1 m2 over r squared. So let's put all the component here, which is F is given the 8 multiple to the 10 to the power 5, and G we have a constant 6.67 to multiple of the 10 to the power of -11, and M1 we have of 5.97 multiple to the 10 power of 24, and we have M2 which is mass for the rocket, and we over here the distance is given 6.37 multiple of the 10 to the power of 6 over 2. Okay, so let's do a calculation here, and we have M2 equal to the 5.07 multiple to the 10 to the power of 4 kilogram. Okay, let's move to the next subtopic, which is 3.1.3. relationship gravitational acceleration g on surface of the Earth with the universal gravitational constant g. So it's asking about relationship gravitational acceleration g on the surface of Earth with universal gravitational constant g. So it's want to know the distance about g, gravitational acceleration g. The normal one we have 9.81 meter per second to the power of 2. So this is normal g. The relationship this g gravitational acceleration with universal gravitational constant, which is g equal to 6.67 multiple to the 10 to the power of negative 11. Okay, we have to know this relationship between these two. Okay, so the formula for F equal to mg is g here is gravitational acceleration is Newton's second law of motion, and we also have F equal to g, which is gravitational constant g, m1, m2 over r2, which is Newton's universal law of gravitational. So we equal to this mg equal to g m1 m2 over r2. So we get here g is equal to g m, which is mass, over r2. So which is this g gravitational acceleration is equal to the gravitational constant multiple to the mass over to the distance to the power of 2. Okay, so the factor that affect gravitational acceleration is distance between the center of Earth and the object, which is r, and the relationship between the distance and the gravitational acceleration is when the distance is increased, when r is increased, the gravitational acceleration will be decreased. So we can state that the gravitational acceleration is inversely proportional to the distance between the center of the Earth and the object. Okay? Okay, so here we have a diagram show a satellite at a height from the surface of the Earth, and we also have r is the radius of the Earth, and r here is the distance of the satellite from the center of Earth, which is the radius of the orbit. Okay, so when we have a hash and r here, hash is the height of the Earth's surface and r is the radius of the Earth. So that means this little r, we have the distance of the satellite from the center of Earth is equal to the radius of Earth plus height of the Earth's surface. So little r equal to the r plus hash. Okay, so how to get the relationship between the gravity acceleration and gravitational constant? We have here the relationship is g, which is the acceleration, g hash is the acceleration gravity due to the gravity at hash, equal to the g, which is gravitational constant, multiple to the mass of Earth over the radius of the distance of the satellite from the center of Earth to the power of 2. Okay, this is the relationship between the acceleration due to the gravity at h with gravitational constant. Okay, so we have this graph represent the relationship between the acceleration due to the gravity at h and the radius of satellite from the center of the Earth, or the distance of satellite from the center of Earth. Okay, so the relationship between two, we have two relationships, which is one is when the radius when the r, which is the distance of the satellite from the center of Earth, is less than the radius of Earth. So the gravitational acceleration is directly proportional to the distance of satellite from the center to the Earth. But when the when the distance of satellite from the center of Earth is bigger than the radius of Earth, so the gravitational acceleration due to the height is inversely proportional to the distance of satellite from the center of Earth to the power of 2. Okay, so this is the graph, and this graph is represent two relationship. Okay, so let's do the example. Mass of the Earth is 5.97 multiple to the 10 to the power of 24 kilogram, and the radius of the Earth is 6.37 multiple to the power of 10 to multiple to the 10 to the power of 6. Calculate the gravitational acceleration on the surface of Earth. So first, let's write down the formula. So the formula we have to use is G equal to G constant, which is big G, and we have mass here, over R square. Okay, so each want to find the gravitational acceleration. So G here is 6.67 to the power of 10 to the multiple of 10 to the power of 11, and mass, we have mass of the Earth, which is 5.97 multiple to the 10 to the power of 24, and we have R, which is the distance, which is 6.37 multiple to the 10 to the power of 6, and in the bracket to the power of 2. So we get here 9.81 meter per second. Okay, so for the next question, a radar imaging satellite orbit around the Earth at a high. So we have a high here, so we have to use another formula. What is the value of gravitational acceleration at the position of satellite? So the formula we have to use is G hash, which equal to the G gravitational constant, mass, over to the G R plus hash to the power of 2. Okay, so G we have 6.67 multiple to the 10 to the power of 11, and mass, we have a mass of Earth, which is 5.97 to the multiple to the 10 to the power of 24, and we have here the radius of the Earth. The radius of Earth that have been given is 6.37 to the power of 6 plus, and hash, we have 4, and for the hash is given 480 kilogram. So but the SI unit in meter, so we have to convert this kilogram into meter, and we get 48000 meter. Okay, remember to convert the unit. So here we plus to the 80000 in a bracket, and with power of 2. So the answer we get is 8.49 meter per second. Okay, so that's it for our class today. We will continue to the next class, and we will do a lot of exercise on this topic. Okay, that's it. Bye-bye.